All right, so we wrote the formulas for geometric up on the top. The a sub n is a1 times r to the n minus 1. The sum of a finite series a1 times 1 minus r over 1 minus r to the n over 1 minus r. And then the sum of an infinite series where r has to be a fraction. Remember, it has to be in between 0 and 1. Can't be improper. It has to be a fraction. Can be positive or negative, but it has to be a fraction. Would equal a1 over 1 minus r. So the first one says, write the first 5 terms of the geometric sequence. This is multiplying. So the first term is 6, but then I do 6 times a negative a half, and that's negative 3. Negative 3 times a negative a half, that's positive 3 halves. 3 halves times negative a half is negative 3/4. And negative 3/4 times negative 1/2 is a positive 3/8. So first term is 6, then negative 3, then 3 halves, then negative 3/4, then 3/8. Be careful with your signs. They should alternate here. Questions on that one? All right, 2 says write the first 5 terms of the geometric sequence, find the common ratio, and write the nth term of the sequence as a function of n. So here's my recursive. It starts with 120, and then I would do 120 times a half, and I get 60, and then I do a half times that 60, and I get 30, and then a half times 30, and I get 15, did it say 5? And then a half times 15, which is 15 over 2, or 7.5, or 7.5. You could write that any of those ways. So that's the first part, right? The 5, so 120, 60, 30, 15, and 7.5 are the first 5. Don't forget the first one they originally give you. Second part says find the common ratio. So what am I multiplying by each time? A half. Good, that's r. And then write the nth term in terms of n, which means, as a function of n, sorry, which means the an formula. So an would equal a1, which is 120, times r, which is a half, raised to the n minus 1. Number 3 builds on that. So it says using the formula from number 2, write the nth term. So I'm taking a10, which would be 120 times 1/2 to the 10 minus 1. So 1/2 to the 9th is going to be 1 over 2 to the 9th, which is 512. And then 120 does not go evenly into 512, so start to reduce it. If you even started with just 2, I'd get 60, and then 2, 56. I could go again, 30, 128. I could go 3 into these, right? 8, 9, 10, 11. Nope, just kidding. I could go 2 again, though. This would be 15, and this would be 64. And then 15 is obviously just divisible by 3 and 5, 64, not by either of those. So it stays as 15 over 64. This is where you have to be really careful with your calculator. Like the instructions on your quiz are going to explicitly state that you have to keep everything exact. There is no rounding. So you can't like do a half raised to the 9th and get a decimal and then multiply that by 120. You got to keep it exact fraction form and then work your way through. So as a reminder, on Friday's quiz, you can use a 4-function calculator only. You can either bring one from home, or this is what the one looks like on, oh, I didn't airdrop it. The one that looks like on Lockdown. Let me see if all right, that's what the 4-function looks like. So this is the calculator that you can use on Lockdown. So don't get too comfortable with anything that raises to a power. You won't have that. If you were to take your iPhone and hold it up and down, this is basically what it looks like. So if you want to practice with that, or you want to buy, they're cheap, but you could buy like at the dollar store, Walmart, Target, whatever. They're cheap. You can get a 4-function calculator if you'd rather not use your iPad. That's completely up to you. All right, 4 says the sum of the finite geometric sequence. So now we're doing a sum. It is finite and it is geometric. So a1 times 1 minus r to the n over 1 minus r. There's 2 ways to find a1. One thing is if this is 1 and this is I minus 1, I just grab the term that's on the front, the thing that's not being raised to the power. So a1 is 12. The other way is if you're unsure about that process, or you don't, it's different, like it's a 1 on the bottom but just an I on the top, then you would take the 1 and you would plug it in to find that first term. Okay, that's what it is. And I would get 12. The r is the thing that's being raised to the power. So r is a negative 1/2. The sign is important there. Obviously, you need to make sure that you keep it negative. And then the n is the number of terms. If the bottom number is 1, then the top is the number of terms, so this is 4. If it's anything else, it's top minus bottom plus 1. So I get a1, which is 12, times 1 minus a negative 1/2 raised to the 4th over 1 minus a negative 1/2. So this becomes 12 times 1 minus. I have to raise this to the 4th power and then take the negative on the front here. So be careful. So this is minus, and then 1 times 1 times 1 times 1 is obviously 1. And it's positive because it's an even power here. If that was an odd power, it would be negative. And then 2 times 2 times 2 is 16. So 1 minus 1/16 over, this becomes plus 1 plus 1/2. You have to find a like denominator here, so I make this 16 over 16 and I make this 2 over 2. 12 times 15 over 16 over 3/2. Then I keep, change, flip. 2 goes into 16 8 times, 3 goes into 15 5 times. 5/8 here. And then 12 and 8 are both divisible by 4. This would be 3, this would be 2, and I'd end up with 15 over 2. You would get the same thing by plugging in 1, plugging in 2, plugging in 3, and plugging in 4, and adding them all together. It's just that obviously the higher that n is, the longer that's going to take. All right, 5, find the sum of the infinite geometric sequence. So I know it's infinite because it says it, but also because that top is infinity, okay? These should be easy to spot. So this would be a1 over 1 minus r. A1 is what's not being raised to the power, because this would be plugged in here. That would make that 0 and go away. So A1 is 6, and R is 1/3. So the only reason we can do this is because what's being raised to the power, that R, is in between 0 and 1. So then I plug it in, 6 over 1 minus 1/3. This becomes 3/3. 6 over 2/3. Keep, change, flip it. 2 goes into 6 3 times. 3 times 3 is 9. Questions on geometric? All right, we've got about 15 minutes before. This is from 8-2, which is important because obviously there's different kinds of sums. It also says partial sum, so that's how I know it's arithmetic and arithmetic. So partial sum of arithmetic is n over 2 times first plus last. So we know n because it's 15. We know the first because it's 6.9. We don't know the last yet. What we can do is set up your a sub n. So an would equal a1, which is 6.9, plus d. So as I go from one to the other, 6.7 minus 6.9, 6.5 minus 6.7, and so on and so forth, that's a negative 0.2. So that's d. So it's 6.9 minus 0.2 n minus 1. And then I want to find a15. Oh, that's easy. Yeah, so just be careful. 15 minus 1, you know where to go from there. And then you plug that in here. Okay, good.